Okay, so here we decide to approach the problem differently. So we choose the direction above the launch point here, the distance or the displacement above the launch point we consider it to be above this dashed line. So any height above this dashed line we consider it to be positive, then any height below that dashed line we consider it to be negative. Then the next thing we do is we consider the time of flight as one hot time, unlike what you've been doing, splitting the time of flight in parts. So for example, what I've been doing previously is from the launch point here up to A, we called that T1, the rise time. Then from A to B, T2, from B to C, T3. In this case, since all those other approaches we have tried have failed, what we proceed to do is we consider the flight time as one hot time, T. In that flight time, the displacement of the coin changes from positive all the way up to negative. So it ends up being negative below this line. So it ends up being negative. So basically our displacement is S is minus 15. It's below this vertical line, minus 15. And the time of flight is T. Then the initial launch point, the coin was moving away from the surface, so our acceleration in this case is positive, and that's what we do. So in that case we use the formula, since we know a couple of things. S is equals to uy. Yeah. S is equals to uy plus t, then plus half equals that. Now I need to change that just a bit so that it becomes S is equals to uy, then like that. So we get this. Oh, hold on. How many of these things now? Okay, so substituting. We get equation minus 15 meters is equals to, or uy, which is u sine 53. How much is ui? We found ui to be something. Where is it? Here, 0.8. Oh my god. That, then t, then plus different 1/2, then minus 9.8, because the coin goes away from the surface of the earth when it is tossed. Just a second. Then t squared. Okay, so we get this. Then dropping the units, dropping off the units, we get get this, and that gives us HT 4.9 minus 4.9. Then what else do we do? We bring the negative, this negative take the other side, so we end up having plus that of having this like that. Okay, now here we have minus 4.90, then 0.8 ut plus 15 equals to 0. This gives us a bit of a problem because there is t which we do not know, which is the entire time of flight. There is also u which we don't know, which is the velocity. However, if you recall very well, recall that we have the expression the following expression from our calculation of flight time. That expression, we've got this, and these bits can just be rewritten as t, where is the flight time. Where t is a flight time. So in this case, making u the subject, we get again equation u is equals to from 6.7 divided by t. When we make u the subjects, we get ourselves this. Substituting in the quadratic, substituting for t, the following equation. We got, so in this equation, we want to substitute for u here. Where is u? We replace with this. So we got t. like this. So when you do this t and that t, they cancel out. So we end up having end up having 6.7. Okay, just a minute. And that gives us what? 53 something. .63 5. Then that gives us 68 8.36 gives us 68.36 like that. Then I can write this as equals to gives you 9.4 4.9 t squared 68.36. Divide both sides. Divide both sides by 4.9. We get equation t squared equals to 68.36 divided by 4.9. That gives you something like 18.95. Then you take the square root on both sides. Take the square root. On both sides. Get 10 equals to 3.74 seconds. That is our time of flight. So our time of flight is our time of flight is 3.74 seconds. Which is that. Okay. Now that we know the time of flight, we can now work out what is the velocity with which the projectile, the coin was tossed. So the projected velocity, the launch velocity, projected or launch velocity, u is given by equation. U is equals to where is that? This. Yeah. which gives us that divided by 3.74, that gives us a cos of 17.8 meters per second. So the velocity. So the launch velocity of the coin, the launch velocity of coin is 17.8 meters per second. Okay, so that is question number 5. Yeah, not a straightforward question, to say the least. Okay, let me stop here.